Hello, how's it going? Got a little bit of a quick repair here. Hopefully we'll have a look at this. Let's get the microscope on the go. Let's just make sure that we're live streaming. Hello, it's David. We've got an ACA1221, another one. Bought another one. What happened to the other one I was trying to fix? Where did that go? What did I do with that? Where did they put that? There it is. Yeah, we got basically I think they're identical. Yeah. Except for one's been warped. Right, I'm just going to make sure I'm live streaming. Yeah, it's live streaming with the wrong information. Hang on. Let me just go in and amend that. Right, so what's that there? Oh, it's a bit of grease. The 3-volt regulator ripped off it. The other one, I've just given it a quick try now, an Amiga 1200. And this one here. Tell you what, let's get it on the microscope. I'll probably be better off. Right, let me just edit this in videos. Okay. Right. So this is an ACA1221 Amiga A1200 Accelerator. I wish I could spell. Accelerator. I've got to use this. Never mind. Accelerator. Memory expansion. Live repair. Okay. That tells on the back. There it is, individual computers. Yeah, 2015 model. What's this one? 2015 model, same model. Okay, it's just okay, save. Okay, that hopefully that'll yeah, that's better. Right, show me. Oh, because I'm still in the studio. Let's get out of the studio. If it'll let me out, come on, get me out. No, it doesn't want to let me out. Okay, I'm going to do it another way. Right, just want to make sure it's live streaming. It surely is. Okay, good. Yeah, that's okay. I'll close that down. Right, so we're live streaming by the looks of it. Anyway, nobody watches, doesn't matter. Right, so this one here. Let's get a better screwdriver. Where's all my screwdrivers gone? Anyway, this one here. Tell you what, let's switch over to the US microscope down view. Let's tune it in. Okay. Let's get rid of the voltmeter. Don't want that, and we don't want the oscilloscopes off. What else? Don't want that one. What else? What is that? headset. What is that there? On the screen, I've got something on the screen here. Text microscope view. No. Workbench top down. USB meter cam. Yeah, that's it. Okay, so I'll just have a couple of screens on. Right, so here we go. Let's turn it round. We're looking at it the wrong way. No, we're still looking at it the wrong way. That's it. There it is. I've got to get my a proper USB microscope. Well, proper microscope. It's not very clear. Why can't I get that clear? It's rubbish, isn't it? Let's go zoom down a bit. Alright, so okay. There we go, it's upside down. Let's turn it the right way up. Alright, there we go. See that little bugger there? That little bugger there, look, see it? See that little bugger? That's your 3-volt regulator. 5 volts comes in that pin. You got ground, and then you got 3 volt 3 should be coming out there, and also on that tab there. But you're not getting 3 volt 3. There's a dead short on the circuit, or this thing's gone open circuit. It's gone faulty. One or the other, not too sure. So we have another one. We've got plenty of these. I use these on my project myself. I don't know if it's the same thing, hopefully. 1117. Looks like the same thing, isn't it? Different numbers. So I'm going to take that off and put this one on its place. Okay, I'll do a few tests first. So what I'll do is this one I'm going to put this one away. So can you see the state of this one? This one, oh, that's a scratch away at this to find some tracks. So this has got to be repaired one day. Not today though. This one stands a better chance of being repaired than that one. Okay, so I'm going to spin it back around. Okay, so what we're going to do now then is just do some measurements. Let's do some measurements. How can I do some measurements? You're not going to be able to see, are you? How can you see that? Can you see that? Oh, you can see that, yeah, in the bottom left hand corner. Alright, let's move this over a bit. Move that over. Can I get it in better in focus? No. It was okay before I touched it. Alright, that's about the best it's gonna get. Okay. Oh. Right, hopefully you can see that meter there. Right, so we're going to just do some tests to see if we've got a dead short on the output. Okay, so we want earth. Hang on. Come down a bit, and then you can see what I'm doing. Yeah, this connector here, these two pins are ground. Which, if I bell out, right, how am I going to do this? So I bell out the middle one against one of these, and that one. That's normal, that is. So that's ground, 0 volts. So that's 0 volts, they're them two. This is 12 volts. This is 5 volts. Obviously it's not plugged in, so you won't get nothing. Okay, so your 5 volts will come into here off this pin. Yeah. See that top pin there? Hang on, you can't quite see. And you're getting a bit blurred. Let me lower the light level maybe. I'll increase the light level. No. That was alright there, wasn't it? Okay. Bit blurred, it's higher up. Anyway, you can see it enough. So the got it upside down. So that pin there is 5 volts. Shouldn't be. There's no short between 5 volts and ground because I've had it plugged into the Amiga 1200 and I was still getting 4.8 volts. So that's about right. This circuit, this regulator powers the Xilinx. I don't know if it's a CPLD or an FPGA, not too sure. It's got a couple of Xilinx and some memory and stuff. So you got here you go, Xilinx. I don't know if they're two the same, are they? 2XL, yeah, it looks like they're two exactly the same. And we got some, looks like memory chips or glue logic or whatever it is. Yeah. Okay. And we got our CPU 68020. Okay. So we're going back to this one now. So we've proved we've got our ground on it. Yeah. And we've got our 5 volts going in. No problem. Now that end one there is 3 volt 3. And that looks like a dead short, doesn't it? Dead short there. So that tab, hang on, you can't see it. Right, that tab there is connected to the output, which is 3 volt 3. Right, so the middle one is ground. Tab is, there's almost a dead short there. Could be a capacitor dead short or anything. So I can't really tell a lot while it's in circuit. So that's got to have to come out, that is. I suppose I could stick 5 volts on there and ground and see what happens. It doesn't really matter that the rest of the circuit isn't connected to an Amiga. It shouldn't matter. I won't do that though. No, I won't do that. It should be possible to put 5 volt and ground there, and then see what this is doing. But I'm not going to do that. So what we're going to do is we're going to take this off now. First we'll do a compare against in circuit one. So I've got in circuit one and see that's showing me dead short to 3 volt. I got my ground and I got a dead short. Let's try it the other way around. Between my 3 volt output. Right, let's stick it on ohms and just have a look how bad the short is. 0.6 of an ohm. 0.6 of an ohm. That's quite a lot. Yeah. So we've gone as far as we can get without taking it off. So What I'm going to have to do now is, do I need to cover anything up? No, I shouldn't do. Oh yeah. I've got hot tweezers, that ain't going to do it with hot tweezers. I've got hot air, I've got soldering iron, so it's going to be a hot air I think to get that off in one go. So a bit of flux to help it along its way. Right, let's get a bit of flux on it. This is where it gets a bit messy. Still streaming. Yeah. Okay, bit of flux. What did I do with my... What did I do with my... Can't find it. Thought I had a load of toothpicks. Where's my toothpicks? Ah, there's one. Right, so we've got some of this. Got some of this solder paste. Soldering paste, whatever that is. We've got a lot of it. Anyway, I'm going to put a bit of this on around the thing. Let's just get a bit of this on to get it going. I like to heat just to get through it, and it's probably way too much. I've got to get that off without touching the rest of the components with a bit of luck. Easier said than done. Anyway, I'm only doing this because I was designing a couple of circuit boards and I've had enough for one down that, and I want to have a play now on with this. Right, let's get the hot air on the go. I've just found my toothpicks. There they are. They're not toothpicks, they're, well, I don't know, skewers. Right, hot air on. Quite high. I think I'm going to cover up the plastic connectors with some Kapton tape, if I can find it. What did I do with it? Where is the tape? Kapton tape. Can't be far, surely. Kapton tape. Can't find anything, can you? This is not a good workshop. Anyway. Unfortunately, I have to spend 48 hours every week on my day job. So, that's my excuse anyway. What did I do with this Kapton tape? How can that just disappear? Could have sworn I saw it earlier. Where the hell is it? That's weird. Kapton tape, where you gone? What the hell have I done with that? Was it down there? Yeah, I see it. Hold on. Right, I've got it. I was doing a job in another room. Here it is. Kapton tape. I was doing a job in another room, so basically never put it back. Right, let's get some Kapton tape. God, right, let's just cover up that with some Kapton tape. Here we go. Because these on the other unit, they melted. I didn't melt them. The guy I bought it off melted it. See the state of that? Some melting on it. It's no big deal, you can easily change it. That one's easy to change, but that one not so easy, but don't matter. Anyway, right, Kapton tape. You want a bit more than that, just one lot. I don't want to melt this one if I can help it. Bit more Kapton tape. I lost it again. There you go. Yes, you're probably thinking I'm insane. Yes, I am. Anyway, this is the first time. Is it Saturday night? The first time I've ever gone live. Saturday night. Oh well. I'm gonna go live because I'm a bit lazy to edit the recording. Sorry about that. Give me a thumbs down for that one, please. Definitely need a thumbs down on that one. Right, anyway, so but there we go. I'll put it in the middle. I don't think there's anything else worth trying to cover up. So we'll get the heat gun on the go. Gonna put a lot of heat on this quickly. A lot of heat quickly. Tweezers, where are you? They're no good. They're cheap nasty tweezers, and them. I bought some nice, dear, expensive tweezers. For some reason, I don't know where they are. And now I'm using the cheap and nasty ones. Oh well. Right, here we go. So we're up to 400 degrees. Is that going to be enough? Can I go any higher? I don't know. Never gone any higher than that. Let's give it a go. 500. I doubt this is going to get 500 somehow. Not a chance. It's WEP858D, the cheap 40-50 pound ones. Right, I'm going to have to just move off slightly now, so I'm going to have to give you a top-down view for a minute. Just going to move that out of the way. I don't want to melt me USB. Right, here we go. Here goes nothing. You ready? Hang on, I've got to get me tweezers ready in the right position without burning them. That's it. So here we go. It's going to be a bugger out. Oh, here it comes. Yeah, he's off. Okay. Right, let's shut that off a minute. So we don't set fire to the wall. Right, let's have a quick look. Go back to the other view. Get that back, so it came off, very good. Did I burn anything? I don't think so, so that's good. Good news. Alright, no damage done by the looks of it, and no other components misplaced. That's even better. Right, so here's a little thing, but it might not be this yet. So I'll just put that to one side a minute. This might not be a problem. Could be something else. It could be something drastic. Could be one of those Xilinx. Alright, that's the one I took off. Let's measure it and see if it's still got a short. I doubt. I think it'll probably be okay. It's going to be something else that's shutting that one down, but we'll give it a go. Alright, so we're on. Just shut that fan off, it's quite noisy, sorry about that. Hello. Right, here we go then. So we know we had a short, let me turn it around again. So I was measuring it and we got a short between ground and 5 volts. Well, 3 volt 3. So let's see if we still got a short. Oh, we have. Or is that ground? You got me confused now. Hang on, let me just bring up a drawing. I've made a circuit with this in it and I just can't remember. Hold on a second. Right, I'm just going to search for this 3 volt 3. It's a 1117. Let's hope I haven't got it mixed up. Something with a data sheet on it. Linear voltage regulator, yeah. Datasheet, where are you, datasheet? Oh god. That's rubbish. Datasheet. Right. Let me show me a picture of it, of the pin out, the package. Just to double check. Output. Ah. Seems I'm wrong. Input is the right one. Output is the middle pin. Ground adjust is the other pin. Right, so yeah. So apparently that one and that one should be a dead short because the middle pin is the output. So that's ground. So I'm not sure if that's faulty or not. Let's just put it next to a brand new one. Yeah, let's just have a look. I don't think you're going to tell. That's the input. Yeah. 0.3. 0.3. So it's looking like there's nothing wrong with this after all. But nevertheless, there was 0 volts. Let me put that one back over there. There's 0 on this. There was 0 volts when it was powered up, and there's voltage supply going in, 0 coming out. So it could be one of these capacitors. Let me just take this Kapton tape off. So we're going to still have a short on this output by the looks of it. Why is it so shiny? Okay, let's try it. So that's an output. That is ground. So I've got a short. That and that middle pin and the tab at the top is 3 volt 3. That's your input, and I shouldn't have a short between ground and 3 volt 3, which is what I've got. So this device I took off, there's nothing wrong with it. Too easy if that was. So what we've got to do now is find out which capacitor is, or is it a chip that's causing this problem. Could be that, could be anything. So what I'll do is put that back. I'll put 3 volt 3 in it. Yeah, I'll connect 3 volt 3 into there and ground, and feed it from my power supply. Make the current very low on it, and maybe put some Zippo fluid on to see if there's anything getting hot. That's one way of doing it. Or should we have an inspect? I tell you what, let's inspect some of these capacitors. I can't see anything wrong with the capacitor. You won't be able to see it. Right, let's just go back to the other plan then. Let's switch the power supply on. Okay, we've got power supply. What have we got here? These clips, these are pretty handy. Okay. So we want 3 volt 3. Tell you what we'll do, we'll switch the power supply back on so you can have a look. Have a look with me. Right, there it is. Camera must have moved a bit. Hold on. There you go. Right, so there it is. We'll bring the volts down. Course volts down. We want 3 volt 3. Yeah, 3 volt 3. 3 volt 3. There you go. Give it a couple more. That's it. 3 volt 3. 3 volt 3. Go on. Why not? There you go. 3 volt 3. Bring down the amps right down so it just switches on. We need a little wire off that now, off the 3V 3 tab. So I need a little piece of wire off it or something. We can just what's this? There'd be a bit of wire. Can't find any cut there. There's a cutlass. Right, so I'm going to cut a piece of wire and just solder it. Let's get the soldering iron on the go. Okay, yeah. I'm just going to solder that onto the tab there. That's a big piece of wire actually. Okay. Right. Have we got any water? No. Have we got any water? I swear I'm going to make a self watering sponge. Shit, we do need some water. Why haven't I got any water? Is this water? What's this? It says screen wash. Looks like water to me. Oh dear, hang on. Let's fill that bottle up from this water. Just filling it. You can't see what I'm doing, but there you go. It's taken a while. This is just you know. It'd be nice if I can get it going. I'd love to get that going. Oh, I think I broke it. I'm not having much luck today. I think I just broke the lid off that. So I ain't going to be able to pour that now, no matter. Right, here we go. Get that sponge, get some water in that sponge. It's like living in a desert, that sponge. Right. So I must have broken this off. Right, so I'm going to have to pour that back in here before I tick it over everything. Things you have to do to get a card working. I've spent enough money to actually buy a working one. Now buying two of them. Who dares wins? So if I manage to get it going and get the other one going as well, I've got at least I can compare things from one to another. Right, where did I get to? Yeah, we got a solder iron, we got a tin of wire. Tin this wire, solder it onto the tab on the board. Let's just tin this wire. Tin the other end. This wire's going to look massive on the end of there. Okay, right, I've just got to get into this now. There we go, I've just got to turn it around. I'm just going to quickly solder that on there without trying to pull the track up. Shit, I made a right balls of that. Got a short on it. That's better, I think. Last thing I want is a bloody short across there. Right, what's it looking like? Have we got any shorts? I don't like the look of that. Oh well. Right, let's get the meter on it. Let's get the meter on it, make sure we got no short between there, that capacitor, and there. And we have. But you may have to have a short there. Right, that's confusing. Let's have a look at this one I bared back. Here's one I did earlier. Oh shit, I don't know. Yeah, it looks like the copper track goes all the way across. Yep, so I think we're okay. Let's just zoom right down. Zoom right down. I just want to have a nice close look at that. Let's get some light on it. Doesn't tell you nothing. It'd be nice if we could get a circuit diagram. Can't see nothing. Looks alright to me. Right, okay, back it off. Okay, so we've got a little wire on it. We can put a ground on it. I'm just going to disconnect that a minute. Right, I've got a couple of probes here. What we got is a couple of these things, can you see them? So I'm going to put ground on one of these cables here. On this connector there, ground. These are awful really for doing this kind of work. These are too big. Okay, that's the ground on. Okay. Now we want 3V 3 on this. Okay, 3V 3 on this wire, so we can monitor what's going on. Here we go. If you watch the middle top of the screen where the power supply is, you'll see it trip out as soon as I do that. Yeah, switched off. So what I've got to try and do, turn it up a bit. Yeah, so we're trying to find out if anything gets warm, which it should do if I give it enough current. Right, here we go again. We tripped out. That's 500 amps it was drawing then. Nearly an amp. So what we're going to do now is going to do a little tip-off soldering of electronics repair school. Zippo lighter fluid. I wouldn't have thought of doing this because I'd be scared, so if I go up in flames, you know who to blame. So let's just start by putting a bit of fluid on. Let's see if we can see anything going. That'll do. I've sort of plastered it. Right, so we plastered with tell you what, let's back off some more so we can actually have a bit of a gander over the whole area. Right, so capacitors normally things that go. So let's see if we can see anything. Put it in the middle. Right, here we go. What we're drawing, 900 milliamps. I can't see anything. Can't see anything actually drawing back the heat. It's going somewhere. The voltage is, yeah, it's coming right down. The voltage, it's not enough voltage, but it's bringing it down. So, can we see anything getting warm? Oh, there you go. I've just seen something, unless that's me. Look at this CPL, whatever it is, FPGA or CPLD. Watch this. See that? There's the problem. That's gone short circuit by the looks of it. So that Xilinx, that's a surefire. And I've got a similar thing. Let's just put it on, see what happens. Yeah, you can see it. You can actually see where the fault is, right in the bang in the middle. I've got a FireWire Motu audio interface 8-channel. It's got a problem with a Xilinx processor. So I've got a downer board here, haven't I? I've got a downer board. So can I swap it over? It's quite a fine pitch on that. It's a bit scary. I better get this going after all. Yeah, so that looks like. So what I'm going to do now is take off the Xilinx processor and see if we still got a short. Okay, so I'm going back to the overhead view. This is taking a while, this. Oh well. 42 minutes, sorry about that. Right, I'm going to have to take that off, temporary. Let's turn off. Just off with the power supply a minute. Off with the iron. Off with this. Off with me wire. Just check it, make sure I haven't shorted anything out. Right, microscope view again. Big blob, it looks okay though, it's not, yeah. Right, so I'm going to take off the Xilinx. Let me just get the petrol or Zippo fluid off on it. Okay, so we want to cover that up again. Cover the plastics up. Right. It won't stick. Won't it stick? No. Oh, well. I've learnt something today. You can't reuse your Kapton tape. Don't try and reuse Kapton tape. It doesn't stick. Especially with all that lighter fluid all over it. A bit more. So let's find out what that Xilinx is in a minute. Is it a CPLD or an FPGA? I'm not sure. We should have a look. Okay, let's have a quick wander. I'm not looking at any, not expecting anyone watching, so that's why I'm not looking at any comments. So we'll have a quick look then, just in case. Let me just turn the quality right down. Yeah, that's fine. Is it moving? I don't know if I'm streaming or not. Is I know. Oh yeah, it's just a bit jerky and slow. Okay. Right. One watching now. That's probably me. Say something. Hello, me. There you go. Right, so we've got it masked off. Do we need another sheet? Let's give it another one. Nah, I shouldn't do. Right, so let's find out what this Xilinx is. Let's have a quick look at this Xilinx. Let's call it what it is. This one is definitely getting overheated. There's hardly any volts on it, and trick from Sorin there, and Sorin Electronics Repair School, and maybe Louis. So let's have a look. XC95 72 XL. Right, Xilinx CPLD. Oh, Farnell. Can we still buy them? Oh, £3.42. Can't be bad. £3.42 for that. That's alright. Ain't worth wrecking the other board for that. It's a CPLD. 5 microcells with 1,600 usable gates. 5-pin to 5-pin logic delays. 5 nanoseconds. Slew rate. Individual outputs. Yeah. Oh well, so you can still get them then, that's good. Features. Any typical applications. Is a 3V 3 CPLD targeted for high performance, low voltage applications in leading edge communications and computing systems, comprised of 4 54V18 function blocks, providing 1,600 usable gates and propagation delays of 5 nanoseconds. Power dissipation can be very substantial depending on the system frequency. Right. Just wondering, would he? No, it wouldn't heat up like that, would it? That's just drawing this current right down. Right, I'm going to switch to overhead view now. So it's a CPLD, not an FPGA. Overhead view. Right. Microscope out the way a minute. Hot air on. Now, I've got to try and get this off. Can I get it open wide enough to get this off? Yeah. Okay, here goes nothing. Just warming up the let's get up to temperature, 500 watt, 500, it doesn't get nowhere near that, it lies. This is too cheap a hot air gun to do that. Right, here we go. Oh, you can't see. You want to be able to see what's going on, surely. Let's get it warm. Hopefully we won't topple any of the other stuff. Oh shit. See what happened there? I'm gonna have to stop a second. My Kapton tape's coming off. Let me get some more Kapton tape. Let's get it on. Let's use that there. More Kapton tape. Can never have enough Kapton tape, probably. Right. Okay. That should do it. Right, here we go. We're gonna go again. I've got to get this in a touch of position. Forgive me if I don't talk much now. There's no... Shit, I'm gonna be careful there. Let's hope I don't burn myself. Set that fire to anything. This is not happening. These tweezers are giving me a bit of grief. Could do with a sucking tool, but that ain't gonna happen. Tell you what, let's put a bit of flux on it. Let's do what we did earlier, put a bit of flux on it. Bit of flux around it, help it off. Okay. Alright, here we go. Bit of flux, let's get it on there. You can't see now. Come on. Oh, bugger. Oh, the on early. Oh, shit. Someone's burning. Come on. Smoke coming off and all sorts here. Shit. This is not nice, it's evil. Come on baby, get off. Yep, he's off. Right, we're off. Thank God for that. So what, we're starting to fry. Right. Thank God for that, eh? So, there's his eye links off. This is stressful, isn't it? Especially if your eyes are going as well. Right, let's put that somewhere. Hopefully that's cooled down enough now to drop it down, yeah. Right, so, yeah, we took the CPLD off. There is another one next to it, but that wasn't showing the same results. Right, so what do we do now? We clean up the area, bring the microscope back, turn off the fan on that thing. Let's switch over to that one. Make sure we haven't shorted anything out. Obviously I've moved one of the capacitors, I can see that. Let's come right down. That's it. Have a good look. Right, let's have a gander. See that? I just moved that capacitor off, but I don't think it's causing any problem. It's not come off enough to cause a problem. The rest is okay. Yeah. Doesn't look like there's any shorts. There's something there. Something there. There. Oh no, it's just a bit of flux. So that's looking good at the minute. It's looking good. Yeah, looks like that capacitor came off as well, a little bit, but not enough to worry about. Right, okay. I'm very happy with that, really. As long as there's no shorts. What's that there? Is that fluid? Tell you what, let's clean it up with a alcohol and a bud. Alcohol and a bud. Here we go. Right. Oh, what's happened here? Oh, here it comes. Oh dear. I bought that because it's supposed to give you the fluid when you need it. Obviously, if you're not working on this stuff all the while, things are out a lot longer than they should be. Yeah, I'm just going to clean the flux off so I can make sure I'm not looking at a reflection. That's the trouble with these non-link free buds. Get this bloody stuff everywhere. I want some lint free buds, really. Right, that'll do. Let's give it a quick try. Just give the area a quick try. That'll do. Okay. So we've dried it. We know we haven't got any shorts. What's that there? Why does that look weird? That looks weird, doesn't it? Not like that much. Yeah, is it okay? Looks a bit tight. I'm just gonna go over that. Do I go over it with something? Better mop it up. I don't really want to mop it up, but let's just give it a drag with the iron, just in case. Yeah, definitely need to invest in a £600 trinocular microscope. Could do one of them. Yeah, trinocular microscope. Who's got £600 floating around doing nothing? Yeah, it's a bit blobby there. Right, the trick is now to get this off without... Do I go over it with a bit of... do I just drag it over, or do I drag it, or just put some solder wick on it? Right, here we go. Let's try and keep this straight. Right, here we go. Is that okay? No. That's better. Oh, what's happened to that? That looks like there's a pad missing. What's that? Is that a pad missing? That's weird. Have I just done that? That is strange. Have I just wrecked it? Have I just wrecked it? Let's have a look. Let's go down. Need to go lower. This is awful, isn't it? Trying to do it with... What is that? What the hell is that? Oh, where's the pad? It's come off. The pad's come off, look. Fucking hell. That's a bugger. That is a bugger. Pad's on top of the other pad. Oh my god. I'll try and have a look what that is. Let's have a look at the data sheet, what pin it is. Alright. Let's try and identify that pin. If it was going to tell me. No, it's not going to show me, is it? Alright, let's have a look. So, pin 1. Pin 1 is over there. Now does it go around? Which way around does it go? Doesn't tell you. It tells you which way pin 1 is. Right, okay. Let's just... Let's try and get the pin out. Pin out. No, it's not telling me what I want to know. God, it's warm in here. Right, pin out. That doesn't tell you nothing. That don't tell you nothing. Got it there. No, that's a different one altogether. Why is it showing me different ones? Well, that's a bit of a letdown, isn't it? It just came off really easy. So easy, unbelievably easy. Crazy easy. All I did was drag it. Drag it with the iron. That's all I did. Maybe it's had a lot of heat and it's... yeah. Did I do it? Or was it already done? These things are terrible to work on, aren't they? I don't know, I'm going to fix that now. I can't see how we're going to fix that. The track comes off just like that. Oh dear, let's get some flux on it. All we can do with this is make it worse, basically. That's all I can do with that. Look at the state of that. All I did was brush it away. How did it end up there? Right, let's get some flux on it again. That's annoying, very annoying. Most annoying. Very annoying, that. Can't even see it, there it is. Where's it gone now? It's not even there now. Where's it gone? It's not on the iron. It's just disappeared. It's gone. Gonski. Is that it on there? I think it might have so tiny it just sit on the iron. Alright, so the only chance I've got now is if there was nothing connected to that one. That's the only chance I got left. Yeah. Right. Let's get it cleaned up. Get the area cleaned up. Yeah, the only chance I got now is if there's nothing connected to that particular pin. I don't like my chances so much. Whatever possessed God to make a chip this small? God never made it. Right, okay. So we've got I can't see a track on it actually. I don't actually see a track going to it. Maybe we're lucky. Maybe there's nothing on it. Might be lucky on that one. Quite possibly very, very lucky there. Right, so I'll leave it at that. So we'll carry on with what we're doing. I'll just have a quick scan and make sure there's nothing shorted, no pins shorted out. Right, so it looks okay down there. Might have avoided tragedy there if that's just a pad with nothing connected that's lifted up. Yeah, we might have avoided tragedy there. I don't fancy trying to solder a pin on and running a wire. There looks like a lot of gap on these at the minute, but it's such a fine thing you couldn't even see it on the iron. Yeah, okay. Right, we're gonna go back up out the way like that. Okay, we're going to solder the wire back on. Got CPLD off. Get the wire back onto the 3V 3 line. Here we go. Down here. Okay, 3V 3 back on. Yep, he's good. No short on that, that's good. Okay. I've got to switch my power supply on and lower the current. Put back the common. There's the common or ground, and we'll connect up this one, see if we still have current draw. Oh, well, good news, the short is gone. We've got 3V 3.5, and the current course, just switch it on to, we're drawing 96 milliamps, which is a good sign. Okay, so I could take off the CPLD off another one, off this one, and pop it over. But are they pre-programmed? I think they are. CPLD, does it get its software from, is it programmed up on boot? Does its logic configured on boot, or is it built in? Back to the data sheet, I think. Data sheet, where are you? Data sheet. That's the trouble, I don't know enough about this. Right. So features. Advanced in-system programmable. Superior pin locking. Fast extra wide up to 90 product terms. Fast concurrent programming, slew rate. I've got a bit of a theory with these, because a lot of people have these in their computer and they have no trouble, but then they upgrade them to the 63 meg and then they change the clock frequency slightly. They pay for an upgrade, and I think it all goes tits up for them from there on in. I think that's what happens. So if these two Xilinx, they're same number, but if one's programmed up with something, the other one programmed with something else, I'm not sure whether it's programmed up and then fed to it at boot up. But if they are, you can't just put one in the place of another. So I've got a feeling the same thing happened to that one. There's the same thing happened to this, where the 3V 3 went over voltage. And that's a hell of a thing to put back in place. So I'm into this for about 100 quid now, these two. gotta be near enough £100. So if I can get one going, at least I could break even. But if I can't, it's a waste of money. Should have just bought a working one, really. Anyway, this video has gone on for far too long. So it's a pity this one's already got a problem. They said they got red hot there. No, they said that got red hot, and they ripped it off trying to get it off. So this one, I don't know if you can just swap. Oh, I don't know. Well, I think I'll end it there. Find a bit more information about whether these are individually programmed up or whether you can program them up. You must be able to program them up. Maybe it's that header there. Maybe that interface there. Your programming header. Right, I think I'm going to end it there. So this will be a 2-part video probably, and you might see me sending these to the hydraulic press channel to get them squeezed. Right, I'm going to end it there. I've had enough for now. Thanks very much for watching. If anyone's interested, and I'll study a bit more about those CPLDs, whether they store configuration data or take it on an FPGA. I'm sure it gets set up on boot. Not sure about these CPLDs though. They probably got to be programmed up. Anyway, that'll do for now. Thanks for watching. Don't subscribe and don't like the video. Thank you.